Hi, this is Trev, or welcome to my blog. Welcome to part 2 of my TIG welding series, where I hope to show you, in simple terms, how to get started. It's all about transitioning from MIG weld to TIG weld on car bodywork, and that's what I do. I'm not an expert TIG welder, but what I can show you is how I TIG weld, and I'm going to keep everything really basic. When I made part 1, I really wrestled with what to do, and I actually ditched about an hour's worth of footage that I'd shot because I realised that I too was getting carried away with too much detail. And this is the problem with TIG welding. You talk to anybody that knows anything about TIG welding and they instantly blast off into outer space telling you all the stuff that you really don't need to know just to get started. And just to get started, I think, is the most important thing. All you need to know are the basic fundamentals, and in part 1 I showed you how to set up the welder. I showed you that all you needed was a bit of base current and a bit of post flow, and we did a pretty good weld. I was very pleased with that weld, and all we can do after that is just improve upon things. So this video, part 2, is going to be all about building upon what we already know. Anyway, confirmation came in the form of an email. Guy wrote to me, said, Trev, brilliant video. I bought a welder a couple of years ago, spent an absolute fortune, researched it to death, bought the top torches, the Pyrex cups, changed the gas over for a better gas, blah de blah de blah. Anyway, I tried to weld. All that was happening was I was just burning out the tungstens and just making a mess of everything. I just gave up because I assumed that it was just something that was beyond my reach. Watched your video, realised I got the earth and the torch, I ran the wrong way. I cannot thank you enough. So, mission accomplished. So this is what we're going to stick to. Basics, simplicity. Let's get cracking. Part 2. What we're going to talk about in part 2 is a couple more setups on the welder. I'll teach you, how to do a bit of upslope and a bit of downslope and what it's all about, for me anyway. And I'm also going to talk about a really important fundamental, cleaning up. So in part 1 I hinted that there would be contamination on the steel that caused the pitting, the cratering and the scale that we saw in the first video. Now, I didn't go through all this because, of course, I want to keep each video as brief as possible. Now, people talk endlessly about using filler rods to neutralize impurities within the material. I would suggest that on materials like this, mild steel, the material I deal with, the contaminants lie on the surface of the material rather than it being impurities within the material, especially on new stuff. I do find filler rods amazing for neutralizing welds, but that's more to do with when I'm welding a repair section into a rusty old car. So let's just start from the start. Let's talk about brand new metal to brand new metal. So the first thing we're going to do is degrease this with painter's degreaser. So I'm just going to use some painter's degreaser. These pump up bottles are really good because you just fill them up, pressurize them, it's all sealed up. Just make sure you remove this from the welding area before you start welding, that's all. So the first thing we'll do is degrease our metal. So we've got our degreaser in the bottle, give it a few pumps to pressurize it. Got a brand new piece of tissue here, just spray some degreaser on the tissue, get our piece of steel, wipe it over thoroughly to get it really wet, and keep wiping, get it really wet. Make sure you remove everything, then get a brand new piece of tissue and wipe it off. This is really important when you're degreasing anything, to make sure you give it a good wipe off afterwards, because then you're not cross-contaminating from the first piece of tissue to the second. So the next process is using these tools. These are the ones I use. These are a Roloc surface conditioning disc that's used on a little mini grinder, or I used a Scotch-Brite clean and strip wheel, probably my favourite tool. See if I can get your part number going on. Yep. And also I use those on a converted die grinder to take it. Always wear goggles because these are pretty lethal, these things. They throw out debris, and if it gets in your eye, it really will get in your eye. Just clean up the welded area. Just make sure that these are new when you use them to clean it up, because it's easy to grab one that's just been used to clean off some underseal or something oily, and then of course you'll contaminate your area that's to be welded. Several people have recommended using acetone as a cleaner, so I've got myself some. So you could use this instead of the panel wipe, then go over the discs, and then finally use this to remove any residue that's left behind. I'm going to state the obvious. People moan at me for doing this, but I don't care. This stuff is extremely flammable, and not removing this from the welding area could prove to be a fatal mistake. I can hear a compressor rumbling in the distance. This is why my bench is clear, finally, because everything that was on the bench is now where the compressor was. Fantastic, I've got a bit of bench space left. Thanks, Rob. I've drawn this simple diagram out to give you another reference so that you can see what's going on when you set the welder up to a certain spec. Now this is the spec we set the welder at in part 1. I'm going to leave it at this setting just to do this little weld test to see if the cleaning process has made any difference. So the torch is set to 2T, so we're on 2T mode. This is our amps, this is our timeline, this is gas. Gas on, gas off. So when we trigger on, so this is our trigger on point, so we press the trigger on the torch and we go straight into pre-flow mode. So pre-flow is preset, you can't change this. If it's set to TIG, then it will automatically do this. So what this does is this expels half a second of gas out of the torch just to make sure there's no air in it, so we've got a nice gas rich environment for the arc to work in. So we got our half a second of pre-flow, and then the amps jump straight up to 20 amps if we've got it set at 20 amps. So we're set at 20 amps, it jumps straight up to 20 amps, and it will just keep going along like that, producing gas, producing amps at a steady rate until we trigger off. So we trigger off, what actually happens then is it jumps straight down to 0 amps, and then we go into our post-flow setting. So the only settings that we had was post-flow and base current, and that's why we've got a graph that looks like this. So it just completes the post-flow to whatever you set the post-flow at. We've got no arc going on, it's just dead off, and then the post-flow just to cool down the tungsten, stop the tungsten from burning out. So we're back at the controls, everything's set as it was in part 1. So we've got 22 amps of base current, the switch is set to TIG, we've got a tiny little bit of post flow, AC/DC, set to DC because we're welding steel. A few people ask this, do I really need an AC welder if I'm only welding steel? No you don't, you only need the DC model, so you can buy pretty much the same model as this, just the DC one, and save yourself a stack of money if you don't think you're ever going to need to weld aluminium or aluminium alloys, because that's what the AC function is for. Everything else is turned off. This switch is the torch control, so it's set in the 2T, not the 4T. 2T basically means it's on off. I'll explain more about this in upcoming episodes and a little bit later on in this video too. So I've got a nice sharp tip on the tungsten. Again, the tungsten's nothing special, it's just came out of the consumables that came with the welder. Also, I'm using the standard 200 amp torch, which is too heavy really. I could do with a lighter torch. I have got a lighter torch, that's for another episode. So I just want to keep everything standard, as all these upgrades are only going to add refinements to the welding. So I got my two plates all clamped together. I'm going to just tack them together as I did in the first part. All tacked up. So what I'm going to do now is I'm going to do a series of runs as it is, and we'll see what the results are. Okay, so I think that weld was a lot cleaner. There was a lot less spitting than there was in part 1, and that's all to do with the cleaning up. So that's the start of the weld and that's the end of the weld. So the start of the weld started good, reasonable ignition, could have been a little bit better but not too bad. The weld's nice and clean until we get to the end. Then we end up with a crater at the end. So let's move on to the next part, the upslope and the downslope. So the last thing I want to discuss on this video is the upslope and the downslope settings on the welder. I've done another graph again just to give you a better understanding of what's actually going on. Explain the mechanics of upslope, downslope before I discuss the reasons why you want to adjust it. So again, we've got trigger on, we've got our trigger off points. So we trigger on, track it down, we've got our pre-flow. Set to TIG, so we get our ½ second of gas, and then the welder starts. But the welder doesn't jump straight to 20 amps. If we've got it set at 20 amps, it jumps up to 5. And then it gradually increases up to 20. The amount of time it takes to go from 5 to 20 will depend upon how much upslope you have dialed in. So the more upslope you've dialed in, the longer it will take to transition from 5 to 20. We just continue along at 20 until we release the trigger. Now when we release the trigger, it won't jump straight back down to 5 amps. What it will do is it will slowly go down to 5 amps, again dependent on what you've set the downslope at. The more downslope you've dialed in, the longer it'll take to get from 20 to 5. And this can be quite alarming if you've never used a TIG welder before, because you're thinking to yourself, why won't it turn off? You let your finger off the button and the thing continues to weld because you're going down this until it gets down to 5 amps, and then you go into your post flow. There won't be any arc, you'll just go to your post flow, whatever you've set the post flow at. Okay, so why is upslope, downslope useful when you're using the TIG welder? What's the point of it? What benefits are we going to get from having the upslope, downslope? Well, obviously I've researched stuff before, I've read what other people have said. And to me, with the stuff I weld, the thin mild steel, for me what it means is the upslope gives you chance to make any kind of position adjustments you need to make. It's not instantly giving you your full amperage head on. I would typically set my upslope to less than what I set my downslope at. So it will just give me that second I need. You know, if I'm trying to weld a joint, just say it was a joint and I just need to move over a couple of millimeters, I can see that we're just slightly off and I can just move it over and then start welding. I don't really know whether this upslope has any beneficial properties as regards to welding more exotic materials. I've actually not noticed anything to do with like shocking the material or anything like that. But basically that upslope for me gives me that time I need to make any adjustments. So we travel along our timeline until we trigger off, and then of course it goes into the downslope. Now why do we need the downslope? For me, the downslope, it stops a crater from forming at the end of the weld. Now this must have something to do with the cooling down process. So the more downslope of course you dial in, the longer it'll take the downslope. What I have noticed is when I'm welding and I've got a nice weld pool going, I get to the end of the weld, I release the trigger. If I've got no downslope dialed in, instantly of course we take the amps off, the welder just dies instantly, so we've got a glowing red spot which will invariably get a crater in the middle of it if you don't have any downslope on. When you put downslope on, it cools down slowly and that crater doesn't seem to appear. Now that's it for me in a nutshell. Now the other thing you can use this for, which is really useful, is occasionally you'll be, you know, say 20 amps is the optimum you want it set at. You don't want to go any lower than that. You might be welding along, you may get to a thinner part, say something's been ground a little bit thin, or you've got to something that's got a bit of rust and you've removed the rust, so it's made the metal a little bit thinner, and you notice that the welder's getting the metal too hot. What you can do is trigger off. You'll instantly go into downslope, but the weld won't stop. So you just go into downslope, so you're going down, and you'll notice that the material that you're welding will start getting cooler. Of course, if you don't put the trigger back on, it will just cool down all the way down to 5 amps. So what you can do is just let it cool off and then press trigger on. When you trigger back on again, it just goes back into upslope, so wherever you are on the downslope, it'll just continue to go up again, and then you're back up to 20 amps again. So it's quite useful for that if you're just using the torch. Again, this is 2T on the torch. We're not talking about foot pedals or anything like that, we're keeping it very basic. So that's what the upslope and the downslope is all about for me. So what I do when I'm utilising the downslope is I start my weld. When I get to the point where I want to stop welding, I just simply release the trigger and let it cool down. If I do still end up with a crater there anyway, because sometimes this can still happen, then I find that this material is then susceptible to cratering. What I can do is I can just get to the point where I want to stop welding, release the trigger, and then as the heat is dissipating, I then travel back up the weld that I've just produced, and this then can stop it from cratering also. I can appreciate this isn't very easy to see, but again, this is the start of the weld, this is the end. There's no like crater now at the end. Again, the start, the end. You can just sort of see where I zipped up and it's just finally finished fizzling out. It's left a tiny little bit of a mark there, but nothing that's like a great big crater, as in part one where we had craters all the way along where the material was still quite dirty. And we just had that harsh on off, and I'm quite confident now that I could weld a joint all the way along and only have one or two slight marks, nothing too much. So I've cleaned the weld up with a roll lock. Under extreme magnification we can see that there are still a few tiny little marks. Nothing much at all. Most of these will have been created when I stopped welding with no downslope. So as I said, it just leaves a tiny little crater without the downslope. The downslope greatly helps. Also got a tiny little bit of undercut just on the edge of that one. Let's flip it over, look at the underside. Of course the underside is not going to look anywhere near as good, but it's still pretty fantastic. Very well knitted together. Penetration all the way through, no problems with that whatsoever. So what can we do to improve upon this? I'm pretty happy with this actually, but what we could do to improve upon it, of course, is use filler rod, because there's no filler rod in this whatsoever. This has just been fused together, and I can use a lighter torch, which will make things a lot nicer, and I can also start using some different tungstens. So that's what we're going to next time round. Well, thanks very much for watching. Hope you got something out of that. My objective is to transfer information across to you in a non-confusing way. Anyway, I had the honour of meeting the great Matt Urch last week.
Where's your comb?
Anyway, in that video I said that I would give away an extreme plasma mug. I asked the question, what is Matt most famous for? And I would have said that it's the mongrel. I know he's done the drift car and lots of other things, and the transit and stuff, but I think the mongrel, so let's pick a winner at random. So the Stubby, you are the winner, my friend, of this luxurious mug. All you have to do is let me know what your address is. Let me know what your address is. You can contact me via email. My email address is in the video description. Just let me know what your email address is, and I'll post this luxurious mug off to you at my own expense, of course. So anyway, I've got another mug to give away, a fantastic, beautiful Artec mug this time round. So all you've got to do to win this is answer the question. I recently did an interview with Artec. What was that interview called? Not only will I give you an Artec mug, I'll also send you out an Extreme mug as well. So just answer that simple question. Anyway, that's it from me, so I will say bye for now.